Chapter 6.1, we're looking at rewriting an exponential function. So we're given the amount y in grams of the radioactive isotope chromium-51 remaining after t days is y equals a times 0.5 raised to the t over 28, where a is the initial amount in grams. We want to find what percent of chromium-51 decays each day. So what we're trying to find overall is what percent of the chromium-51 decays each day. We're trying to find R. Now it says decay, and so we are looking at the formula y equals a times 1 minus R raised to the t. So again, our goal is to figure out what R is. Now notice what we're given here. We have a is 0.5 raised to the t over 28, and so there's something a little different here. We have the 1 over 28, and so we need to somehow change that. So we have to evaluate that first. So the first thing we're going to do is we're going to take this formula. So I'm going to take the model they gave us, y equals a times 0.5 to the t over 28. Now I'm going to tell you right now that it doesn't matter what that is. We're not going to work with that at all. Our goal is to solve for R. Okay, we're going to solve for R. So what we're going to do is we need to separate this 1 over 28. So we're going to use the power of a power property, and we're going to separate the 1 over 28, right? So we're going to separate it out. Now it's 0.15 raised to the 1 over 28, and then we're going to push that t all the way to the outside. So power of a power property, right? Remember, I can multiply it back together. 1 over 28 times t is t over 28. So I didn't really change it. I just kind of rewrote it a little bit. So now what I can do is evaluate what it is inside here. Okay, so that's the very first step. So you just use the power of a power property, separate the 1 over 28. So now we can evaluate it and we can figure out what the inside is here. That's basically our b, right? b. And so what we're going to do is we're going to plug it in the calculator. So in order to plug it in the calculator, you're going to type 0.5 and then the caret or the y to the x button, whatever it is to get to the exponent. Then do parentheses 1 and then divided by 28, close parentheses, and then an equal sign. So when you plug that all in, you should get 0.9755 and then 4. So we're only going to 4 decimal places. And so again, you're going to look one more over. So it's a 4. So we're just going to stop at 0.9755. So that is the number that goes in here. That is essentially our b in the equation. Y equals a times b raised to the t. Okay, so just all the way back from the beginning of this section. Or you can think about it, this 0.9755 is this 1 minus r. Okay, so that they're all equal. So now what we're going to do is we're going to substitute that 0.9755 into the equation here. So it's going to be y equals a times 0.9755 and then raised to the t. And so just kind of like in the previous examples that we did before for like the solving a real life problem, we're trying to find R. We're trying to do that here as well, just one more extra step. So what we're going to do is we're going to set the 0.9755 equal to the 1 minus R so we could solve for R. So 0.9755 equals the 1 minus R. Now you probably already have this plugged into your calculator, so don't clear it. What you're going to do is we're just going to subtract 1 from both sides. So if you have it in your calculator, subtract 1 and then equals, and then you'll get negative 0.0244 and then 5. So I guess you could say it's negative 0.0, so it's 1, 2, 3, 4. So it's up, so 0.245, right? So it's higher, so we're going to change that. That equals negative R. And then so divide by negative 1. So now we find that R is going to be 0.0245. Now we want it as a percent. So what we're going to do is we're going to multiply by 100, or you can move the decimal place over 2 times. So that will be 2.45% is the amount that decays each day. Okay, so it's just a little bit more extra steps. The most important step that you're going to do is you want to be able to first use the power of a power property and then take the t out all the way to the outside so you can evaluate this number inside and then plug it in your calculator. Then what you're going to do is try to solve for the r value after that. So try out the example here, pause the video, and see if you can try it out. So if you tried it out, you should have gotten 5.19% would decay each hour. So first you would separate out the t over 13, so 0.5 raised to the 1 over 13. Then you plug it in your calculator, and you should have gotten 0.9481. Now remember to set the 0.9481 equal to the 1 minus r. So subtract 1 from both sides to start solving for r, and you get negative 0.0519. And then divide by negative 1, of course, so you would make it positive. So r is 0.0519, and then so that's a decimal. Now it wants the percent, it asks for what percent, so multiply by 100, and you need to find that's 5.19%.